Hi, this is Math 1115 Remote Delivery for April 22nd, 2020. This is part 2 of 4 parts. I'm slicing it that way. This is section. To add or subtract fractions, you need to have a common denominator. And if you have a common denominator like C here or C here, you add or subtract the numerators. And so, for example, if I have 9, 9, and 9 as my denominators, I just add and subtract the numerators and get 1/3. Here I have AX, 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 so I just can add the numerators all over AX. This minus sign is times the whole of that, and simplify and get this. So you need common denominators, and you're fortunate sometimes to have common denominators. But sometimes you don't have a common denominator, and you're well served to find the least common denominator. So you consider each denominator factored into its prime factors, and every factor must be represented in the least common denominator, and it must be represented to the highest power to which it is raised. So let's do a couple of examples. Here we have 2 squared a squared b, we have 2 times 3ab cubed, we have 2 squared ab squared. So the highest power that 2 is raised to is squared. The highest power that 3 is raised to is 1. The highest power a is raised to is squared, and the highest power that b is raised to is cubed. So 12a squared b cubed is our least common denominator. Here, if we're looking at the least common denominator of these 3 terms, this one, and this one, and we factor them, we'll see that factoring this is x times x minus 1, this is x minus 1 times x plus 1, and this is x minus 1 whole squared. Well, x minus 1 is a factor in each of them, but the highest power is x minus 1 squared. X plus 1 is another factor, and so is x. So the least common denominator is this product. In order to add or subtract fractions, then, what we do is we create this denominator, even if there weren't the same denominators to start with. So, for example, in this problem, I have not the same denominators. But the least common denominator in this case is going to be 3 r squared s cubed. So I say, what do I have to multiply top and bottom in each term to get that as my denominator? So here I have to multiply top and bottom by s cubed. That's multiplying by 1. Here I have to multiply top and bottom by 3r. That's 1. It doesn't change the value. And here I have to multiply top and bottom by r squared s squared. Then I have a common denominator. I combine my numerators, adding and subtracting, and I get this answer. More examples. Now here I have x minus 1 and x plus 1. They have no common factors, so the common denominator is going to be the product of the two. So here I have to multiply top and bottom by x plus 1. Here I have to multiply top and bottom by x minus 1. Then I have a common denominator is this one, so I add and subtract the numerators and get this solution. Here I have s plus 4, and s plus 4 whole squared. Again, factoring these is important to find the least common denominator. So what I'm going to do is multiply all the way through by 1 in such a way to get s times s plus 4 whole squared. So here I have to multiply top and bottom by s plus 4 squared. Here I have to multiply top and bottom by s times s plus 4. And here I have to multiply top and bottom by s. So then I have all of this over the common denominator. I expand, do algebra simplifications, and I get this expression at the end of the problem. A complex fraction is one in which the numerator and denominator, or both, have fractions into and of themselves. So here is an example. So I have, I'm going to get the common denominator in the denominator. So this is going to be 1 over 1 minus 4 over x. So the common denominator is going to be x. I have to multiply it here, top and bottom by x. So I get 2 over x divided by x minus 4 all over x. But this is the top divided by the bottom. When you divide fractions, you invert and multiply. These x's are going to cancel one with another. They're a common factor. So the answer is 2x minus 4. 2 over x minus 4. Here both the numerator and denominator are fractions. So here, in the same way I did up here, I'm going to say this is 1 over 1. The common denominator is x, so I have to multiply top and bottom by x. That is x minus 2 over x. In the denominator, the common denominator is going to be x times x plus 4. And so what I'm going to do then, here I have to multiply by x plus 4, top and bottom, and here I have to multiply top and bottom actually by nothing, and so I get this. Now I have the numerator divided by a denominator. So what I'm going to do is invert the denominator and multiply. Again, the x's are going to cancel, and I'm left with this expression. I'm going to encourage you to pause and see how you do on these problems. Let's see how you did. If you didn't get the right answers down here, figure out why. I'm going to see you now in part 3, wherein we'll use our learnings to solve some equations, an important application. See you.